Yes, am I audible now?
Yeah, it's fine.
Yeah. Okay. So coming to the point, when as I was just discussing. Okay. Yes, please mute yourself if you don't have anything to speak, please. Yeah. So when we do have a streaming requirement, say for example, if I'm using a D streams, Apache Spark D streams or just Spark streaming. Okay. So when we go ahead with kind of a delay, say, but the thing is like when my requirement states that there should be kind of a streaming source and streaming destination. Say for example, if I have file system as my source, where my data is keep on coming and falling out, right? Where my data is keep on falling out, then I need to take the data, process it, and put it out into some NoSQL DB. Okay, some NoSQL DB. In that case, I'll go with these streams. But in case of structured streams, we do not have much privileges to consider many sources and many destinations. Going forward, you'll understand. These streams is kind of very easy to use, very comfort to use, high compatible to use. But structured stream is not that way. Structured stream is only limited to few scenarios in which going forward you'll understand. Okay, as I just mentioned in the high level, the data, my source is streaming, my destination is streaming. Say for example, I do not have any DB there. DB is not a streaming. Cassandra DB. Okay, I took the data from Kafka, put the data to Cassandra. Source is my streaming, like kind of a message queue system who supports more on streaming. But the destination is Cassandra, which is not a streaming engine. It's just a storage. There, I can comfortably take a data from some NoSQL DBs and then put the data into NoSQL DBs and consume the data from message queuing systems. Everything I can do in these streams. But structured streaming, as I mentioned, is just for the limited source and destinations. Going forward, you'll understand from the next slide. Clear, right? As I mentioned, structured stream is only suitable for the place where I have streaming source and streaming destination. Number one, please note it down. Where there is a streaming source and streaming destination. Number one. Number two, no much integration patterns. No much integration patterns. Number two. Number three,
Sai, Vasu.
yeah, Vasu.
In the first point, you mentioned streaming source and streaming destination, right?
Yeah.
So it should be same. Like, for example, from SQL to Cassandra, we can do it, right? I mean,
No. Streaming source in the sense MQ, file system.
Okay.
Socket.
No. Actually, SQL will be considered as structured only. I mean, in such case, will it be?
No. I'm saying streaming source. Streaming source in the sense. I'm saying where the structured streaming can happen. Not SQL. SQL is a DB, right?
Yeah, understood. But here, can we consider the SQL as a structured?
No DBs.
No, right? Okay.
So streaming source, MQ, file system, socket, then Yeah, for now, you can just consider this for now. And destination should be MQ, message queuing, that to Kafka, not even MQs. Then console, you can ask me what is console, I'll come to that. Then memory, and few more, we'll come to that. So when I have a streaming source especially is in the sense, I'm having a file system in which the data is keep on falling out to that file system. I need to consume the data. That is possible. Data is coming from Kafka. That is possible. Data is coming from socket streaming to a particular port of particular host. I have a host name in a particular port. The data is keep on streaming. In that case, I can able to stream the data. And streaming destination, Kafka, again an MQ, console and memory. Memory is nothing but caching. So we're gonna do that all today. We're gonna complete this everything. Okay, no much integration patterns for sure. There is no integration. Not much with Cassandra. Not much with integrations with RabbitMQ. Nothing like that. Spark streaming can D streams can fit on to consume the data from MQ, RabbitMQ, ActiveMQ. But structure streaming you don't have much options. We'll have very limited options. Even the integration as well as processing. But you can ask me where the structure streaming actually fits in. Okay, so take for example, for example, so if I have a streaming source, I have a streaming destination. Okay, say for example, if not about the streaming source, just I have source and destination. Just consider Kafka. Consider Kafka. So I need to in this requirement. Okay, I need to take the data from Kafka, then convert the data to do the process, then put the data to Kafka. Right? This is one of the requirements which we need to achieve. Say for example, I took the data as a RDD. Say for example, I'm consuming the data as a micro RDD, which is nothing but D streams. Then convert the data to data frames. And convert the data to data frames. Okay. Then do the process. And do the process. Then I can't directly, if I want to put the data to Kafka, I can't put the data directly into as a data frame. But I have something known as, I need to convert that into RDD again. That is possible. Spark RDD to Kafka. I'm just telling you, when my source is Kafka, destination is Kafka. Only this requirement, no other requirements. Okay, I need to take it as a D streams, RDD to data frames to processing to RDD. Then I want to put the data to Kafka. These many I need to perform. This is Spark streaming. But when it comes to Spark structured streaming, this is something very important for you to understand. Okay, the data first directly falls into a data frame. Data directly falls in a data frame. You can ask me whether the data should be structured. No, not required. The data can be JSON also. The data can be ORC also. The data can be CSV also. Doesn't matter. Doesn't matter. Directly the data falls and comes into data frame. Then processing. Once the data comes into data frame, one process will be taken care. Process will be taken care. Once the processing is done, I mean to say SQL operations, I can directly push the data frame process into Kafka. Please note it down. If my source is Kafka or socket or file system, and destination should be definitely a Kafka, only Kafka. That's it. Kafka or console or memory. I'll come to that.
Okay, yeah. Okay, which concept of I don't know.
You know who is that user?
1 hour, 11:30, 11:50 like that.
Is it Elango?
Concept problem.
Sai,
Yeah, Vamsi.
Sai, in the first flow, after data frames, we are doing processing. After processing, can we give directly to Kafka without converting into RDD?
Not possible. Not possible because data is inside a data frame. We do not have such integrations with data frames.
Oh, okay.
Got it? So we do have a, see, to put the data into Kafka, I need to create a producer configuration. This is actually the task. Next task is for you. Create a producer configuration, push the data to RDD. At the end of the session, I'll discuss. Once a process is done, I need to convert it into an RDD. In that producer configuration, I need to provide topic name. I need to provide topic name and RDD. Once I provide a topic name using this producer configuration, it pushes this RDD data into Kafka. Only that integration is possible. Then again, see, definitely we know that data frames is high in performance due to its SQL configuration plus Catalyst optimizer. SQL highly easy to use and good in performance. But while putting the data into some MQs, especially Kafka, okay, we need to create a producer configuration. Then I need to create a topic name. Then I need to convert that into an RDD, and I need to provide the data. But here, the data which comes into Kafka, say for example, you can put it this way. The data is so huge. The data which comes is so huge in the file system or Kafka. File system or Kafka. The data is so huge, but down the line, out of this down line, I'm having a dstream process. Here also I have Kafka, okay? Or let me put it this way. I need to perform a dstream process, which is taking a lot of hell of time. I'm taking with the dstreams because of the files it is coming, but it's taking a lot of time to reach the destination. Instead, we can complete the maximum process. What I can do is from this Kafka, I'll just route it to other Kafka topic, from here to here. But in between, I'll apply structured streaming. I apply structured streaming. And here again, I'll perform the dstreams. For example, there, at least in this structured streaming, I can achieve the performance, but the data should be highly compatible for the structured streaming. We have limitations. Or not every data can be processed. Not every DBs or frameworks can be integrated. Here I need to perform, then I need to provide it. Then this Kafka topic gets very limited data. Then the dstream process will be taken care. Here one of the scenarios. The second scenario is the data is keep on falling into a file system. The data keep on falling into a file system. Then what I have to do to process this data is I need to consume the data. Say for example, I have to use NiFi to get file property and put the data to some topic. That is also possible. But still, if the data is so huge, again, dstreams, yes, obviously dstreams can able to provide the streaming concept, but not as good as structured streaming because of the so many transformations we need to provide. RDD to data frame to RDD, process, everything. But here, if your data is suiting everything for SQL performance, then I'll simply go with structured streaming. simply structured streaming. So especially guys, when we have a streaming source and the streaming destination at one case, and other case, okay, in the other case, and we do have if we feel that we can able to perform everything in an SQL manner, then it's always better to go with structured streaming. Going forward, we'll understand what are the issues we face, what are the advantages, and what are the limitations. Getting it right, all of you? Guys, any questions so far with the explanations which I have provided?
Sai, in structured streaming, data frame to directly we can put the data in Kafka.
Yes,
Okay.
possible. From the data frame, it is possible.
Okay.
Yeah, we'll see that. We'll be executing it. Yeah. So let's go to the next slide. This is very basic information. Okay. The very basic information. Okay. This is a kind of a slide, a kind of a benchmark slide for everyone. These are the few streaming APIs we have. Okay. So this just a kind of a structured streaming. What's the difference between streaming APIs? How it actually happen? Okay. So say for example, streaming API. The first one is take structured streaming is one of the APIs in Spark. Spark streaming, Apache Storm, Flink, Kafka Streams, Google Dataflow. That is also one of the frameworks. Okay. So take it as a point. Kafka Streams. Kafka is also having a stream processing capability. But as I think I mentioned to your batch that it's not provide that performance when we try with Spark and Kafka, then Kafka Streams. It's not as good as Spark streaming, but still Kafka works well for MQ. But Kafka Streams is not good in processing. Kafka Streams are used in processing, but it not provide as good a performance as Spark. But instead, Kafka is very good in MQ process. Okay. So coming to the first one, streaming APIs, incrementalized batch queries. So what is incrementalized batch queries is, I'm getting the data. I'm applying a query on top of it. On top of it, what the data is getting received, there will be incremental of data processing. That means data will be keep on coming. The data will be incremental. That the query will be ready. Then the data which got into the structured streaming, I mean to say, once the data fall into a data frame, immediately the query gets triggered. Yes, can you hear me? Yes, am I audible?
Yes.
Yeah. So the query will be ready. In structured streaming, the query will be ready. It's not a batch, like it's not a pure batch. Okay. It's not a pure batch. The query will be ready. So once the data is keep on flowing, the query gets applied to it. Coming to Spark streaming integrates with batch. That means data comes as an RDD. Since you saw Spark streaming, I can tell you like Storm, Flink is a different story again. So in case of Spark streaming, the data integration, the data processing comes with the micro batches in which I need to integrate it with the process. Then I need to connect into data frame. So many things will happen. Storm is something streaming only used for streaming. No process is possible. We can't able to process it separate from batch. I mean to say, I can't able to do any batch processing there. I can't able to do any process. I can simply stream the data easily. I can simply stream the data easily. I'm on Storm, Flink, Kafka Streams. Like it will simply say like I can't able to do much of internal. I can't able to take much of the data and process the data. Instead, I easily can stream the data as good as you. I can stream the data, but I can't apply any process. So as far as streaming APIs is concerned, integrates with batch. See, Google Flow is also a kind of a streaming API in which we can process once we receive the data. So it's all about the processing. But here in case of structured streaming, if I have any queries, the streaming data gets applied directly to the query. It will be a bit tough to understand, but going forward you'll understand. Getting it, guys, all of you? Just a minute, guys. Yeah, sorry guys, I suddenly got a call. So that's what the streaming APIs is. Prefix integrity. Prefix integrity is nothing but maintaining the consistency. Maintaining the consistency with the records. Especially this before streaming API, we spoke about the first point. We spoke about data processing. Prefix integrity is nothing but we're talking about the integration. We're talking about the integration. Like we do have any streaming. Whether we have any integration with many frameworks, like maintaining the consistency when I put the data to Cassandra or NoSQL DB. It's all about data pipelining or data integration. Structure streaming is good with integration, like even though it has any limited integrations, but at least it is good in integrating with Kafka and other memory managements or consoles. But in case of Apache Storm, Flink and streams, Kafka streams, it will just do an internal process for itself. To integrate with it, again, I need to do some provide some integration concepts, integration properties. Then I need to put the data using some other frameworks usage. That's it. Not like integration, like take Spark streaming. I can take the data from ES, Elasticsearch, put the data to Cassandra. I can take the data from Kafka, put the data back to Kafka. This kind of integration, this is nothing but prefix integrity. That is something very good in structured streaming and Spark streaming. But in case of Storm, Flink, and Kafka streams, it will just do the internal processing. But for the integration, I need to bring some other frameworks to integrate it. Number 2. Coming to third point, internal processing. Okay, internal processing is nothing but once I take the data. Say for example, once I take false the data into a data frame, or once we got the data into these streams, okay, it will take up a flow. It will take up a flow, and once we provide any process to it, the data which got streamed get processed immediately. Once get processed immediately, then the data reaches to the destination. Because you remember, I streamed the data, D streams, then I provided some process to it, then I filtered username, okay, then I filtered username, then I process the username, removing the numbers, then I put the data back to Cassandra, So it's a single step process. Once the data received, process completes and the data reaches to the destination. It's only once. It gets applied only once. That's what Spark structure streaming and Spark streaming refers to. But in case of Apache Storm, the streamed data can be further processed for the further streaming. I mean to say, I can able to divide the streaming into multiple frameworks. If I say all this, you may not be getting pure idea because you just saw streaming and Spark structured streaming. You're gonna see Storm, Flink, Kafka streams are a bit hard to understand because since you didn't come to it. But I'm telling you in the very high level. So here, when the Apache Storm comes into picture, they can able to take the streaming data. Again, I can able to stream it to different pipelines. We call it as different branches and pipelines. Streaming it. It's not like take the data, process it, put it somewhere. I can able to send the streaming data to different branches. Right? In Apache Flink, again, I can put the process, take the data, process it, and put it back in some other MQ or some other process. But still, For the Apache Flink to process this data, that can't be done internally. Instead, it need an extra framework, additional framework. So don't think much on other four. We'll just stick on to Spark structured streaming and streaming. But I just want to give a clear idea, bit of idea for you. Both the same. So coming to traditional sources, sinks, okay. Actually, this is wrong. Some should be here. The tick should be here. Some should be here. Okay. Structured streaming, some. That's it. It should be. We can able to take the data Spark stream anywhere. Like I can able to integrate with traditional sources. Sinks. I told you right. Sinks. SINKs. Traditional sources. I take the data from RDBMS. Stream the data. Put the data to RDBMS. I can take the data from Cassandra. Take the data from Cassandra. I can put it back. So traditional sources. It is easy to fetch with Spark streaming. The sum should be here. The tick should be here, as I mentioned. In case of Storm, even though I'm using extra frameworks, remaining things, these two don't have a privilege to integrate with many systems. Not all the systems can be connected with Flink and Kafka Storms. Apache Storm. Kafka Streams is nothing. We do not have integration at all. First of all, there is no integration. The data which comes into MQ, we can just process it and put into the same MQ, the same topic. That's it, Kafka Streams. We can't able to integrate with Cassandra, nothing like that. That is not even possible. Google Dataflow, the same. That is a framework which internally processes its own messages, but it don't have a privilege to integrate with many things like traditional sinks. Okay, interactive queries. Query, you can able to easily.
What is the sinks?
Sinks is nothing but, yeah, you'll understand. Here you have sinks. Sync is nothing but integration with the systems. See, structure streaming sinks means it can able to sync with file, it can able to sync with Kafka, it can able to sync with console memory like that. Sync is nothing but integration, Vamsi. Simple.
Okay.
Yeah. Coming to interactive queries. Yeah, you can able to easily understand what is querying. Whether I can able to perform SQL operation. Simple. Whether I can able to perform SQL capability. Interactive queries. Getting it right? In Spark Stream, we convert that into data frame. We got the data in the form of a D streams. Then I provide the data into JSON. Then convert into data frames. Then I can query the data. I can provide the interactive queries. The structure streaming is highly only for data frames. Animesh, please check your surroundings, please, all of you, please. So that's it. So kind of SQL querying. Is it possible for SQL querying? In case of my during the interactive queries, but in case of Storm, Flink, Kafka Streams do not have any SQL. It's all about the Scala programming. We have, in case of Kafka Streams, completely Scala programming. Storm is different. We can do it in Java or Scala. It's not like I can able to perform any SQL querying there, but it is possible in structured stream and Spark streaming. Spark streaming interactive queries is one of the options because I can perform RDD also, but Spark structured stream querying is the only option we have. We do not have any other options. Okay, today you'll see that. Joins with the static data. Since we have SQL capability, obviously joins would be possible with the static data, with the static data frames. Getting it? Static data in the sense I have a file. The data is keep on streaming. I have a file as a static. Say for example, I have two data sources. One data source is Kafka streaming. Second data source is static file. I can read the data from file as a data frame. I can able to get the data coming from Kafka as a data frame. Then I can put a join for both the data frames. I can process it further. Getting the point, right? Joins with static data.
Yeah, it's Sai, first point I have still some doubt.
Which one?
Incrementless batch queries. Can you repeat that point, Sai?
See, okay. We have query ready. Okay, just think that in your right hand you have a query, right? You have a query, some SQL query, incrementless batch queries. Okay, Vamsi.
Yeah.
In your left hand, the data got streamed and reached to your left hand. Okay. Immediately I can apply this query to it. Incrementalize the batch queries. The data is keep on coming into this left hand as a data frame, as a data keep on coming. My query can easily apply to it. My query can easily apply to it. Incrementalize batch queries. Getting the point?
Okay.
Once the data reaches your left hand, my query in the right hand can easily go and get the data. In Spark streaming, you remember I can't immediately do the query for it. It comes as a data D streams for it. Yes or no? It comes as a key value pair. I need to fetch the value that comes as a D stream. Then I need to do a for each RDD. Then send that RDD into a spark.read.json. Then I got the SQL. Then I got the querying part, right?
Yeah, correct. I got it.
Yeah. This is something we do not have any querying part. So this is separate from batch. All this. Everyone clear with this explanation, the basic explanation of it? Any doubts? Good to go, guys.
Yes, sir.
Yes, Sai.
Okay. So I hope I'm audible to everyone.
Yes, I audible.
Yeah. So that is nothing but the guys. We are in advanced too. So industry is expecting this. Even though the lead or an architect in the projects is not aware of streaming or advanced concepts, they expect such a kind of people to take the project forward. So they expect more on advanced tools concepts, not much on high war scope. I'm telling you again. So please make sure that you concentrate more on this. Okay. So going forward, you'll understand about Spark structure streaming. It's not complex. You have to accept it. Simple. It's not complex. Okay, this is what Spark structure streaming is. Just I have to accept it. Okay, only these are possible. Not everything is possible. Such a kind of things you need to do. So this is what the difference is. Input table. Something you need to understand. Very important. Okay. See, it's not how the Spark structured stream usually happen. I told you, right? Everything falls in. Now I am coming to a bit deeper to the concept. Just have a look. Something very important. You have an input table, virtual input table, very virtual input table. I have a source. I have a source and I have a destination. I have a source. I have a destination. Okay, I'll tell you what is this. This is what is Spark structured streaming is. There should be a virtual input table. For us, it's kind of a data frame, Spark data frame. Once the data from the source keep on falling into my input table, when the data comes and falls into my input table, say for example, the data is falling, the data will fall like this. We'll directly make the data to fall in a data frame. Any data that may be JSON data, that can be CSV data. You can able to see a JSON data in this data frame. You can easily see that. Okay, it's another. How the structured streaming works is between the source and a destination. I have something known as input table. There's something known as input table. This input table is nothing but incremental input table. Since this is just a virtual, unbounded input table. Just note it down. Unbounded. That means there is no limit for it. an unbounded input table. Okay, so whatever the streaming source you're keep on putting the data there, this input table will be keep on getting filled. Okay, suddenly what happened? Suddenly this data has come. Okay, let's put it this way. This information has come. Okay. Sorry, this information has come. Okay. But how you need to do it is, just one sec. Yeah. So how you need to do is, once you get the data, to get the data from this source to this input table, I need to use something known as read stream. Read stream. Read stream. To put the data into destination, we need to use write stream in structured streaming. Please note this down.
Sorry, here input table in the means, is it database table or in memory table?
It's completely in memory. Spark is completely in memory.
Okay, okay.
It's a pure unbounded Spark data frame. Simple to say. Spark data frames will not have any physical location. Those are just virtual data frames, virtual tables. Okay, say for example, I have a Kafka source, I have Kafka destination. Okay, I have a Kafka source and Kafka destination. If I put a read stream, immediately the data will be read and put over into the input table. This is nothing but the process. I just wrote it as a process, SQL process. It's nothing but a SQL process. Once I'm doing SQL process, I can perform write stream for it. First, the data comes and falls into this read table, input table. That is something very important for you to understand. Okay, clear so for all of you? Any questions right now? The data will be read, put into input table. Okay, from that input table, the data will be streamed, processed, and put the data to destination.
Hello, sir.
Yeah,
Here's a question regarding this.
Yeah, Jay.
While doing any process, we need to create a table, right, with some name, so that it will.
No. Here, that is not the concept. Here, that is not the concept. Once I do a read stream, that comes into the virtual table. Simple.
So the lifetime of this input table is like whenever the read stops, it will vanish.
No. As far as Spark structure streaming is concerned, the data will be there in the memory. That's it. Data process will be so huge. Jay, can you even understand?
Yeah, yes, I like. So the data stream will be whenever the happening, this input table will resets.
Perfect. Right, I'll just show you one basic example, okay? One very basic example. There's a hands-on doc for you, okay? Guys, you remember, I took you remember one of the operations during the workshop? I took the data using the Bootstrap server's Kafka properties. Then I read the topic. Then I created Kafka utils. Then I created Kafka params. Got the data, got the D streams. Got the D streams. Then got key and value. Then I have provided and I've done for each RDD. done the process using SQL, convert the data into data frame. Using the data frame, I used regex functions to remove the numbers in the username. Then I write it into Cassandra. Yes or no? You remember that? All of you?
Yes, sir.
If I need to convert, if I leave out the Cassandra, if my destination is Kafka, then I need to convert into an RDD. Then I need to push the data to Kafka topic. The entire process is completed in structure streaming by just these lines. See, Spark session, okay? You remember for D streams, we have used streaming context, which is nothing but a microbatch RDD. Here I'm using Spark session. Can you see that? Spark session, read stream, format Kafka from all this Kafka params, load. From that, it's a single step. It's a single line step. You can see the dots. From the data frame, I can do the select operation. Then I can convert that into a data frame read. Then I'm selecting the data frame. This is a kind of a structured streaming concept, okay? With column, I used result. Then I selected that username, applied regex replace, selected the value. From here, see here till here, it will get the data from the data into input table. Here the processing will be done. Once the processing is done, that will be writing it to Kafka, to this particular topic, to this particular host name. That's it. You're getting the small idea on it? How read stream? You remember how to read a JSON file? We usually read as spark.read.json, right? Spark.read.format JSON. This only read the data. Similarly, spark.readstream.format.
Sai, this is Devashish.
Yeah.
Sai, I got actually a JSON file. I was trying to convert it into a data frame. Even it is multi-line, I enabled it, but it was not converting into a proper format. But it is a valid JSON.
Okay, Devashish, we'll discuss on it. Show me the JSON, we'll discuss on it.
Yeah, I can show it to you.
Yeah. So in case of our streaming, spark.readstream.format, we usually give it as Kafka, what is a source for it? Whether it's a CSV, format is CSV, but it's not a read, but it's a read stream. Please note it down. It's not read, it's a read stream. Whether data is from CSV, whether data is from, I mean to say whether the data is from file system, whether data is from like Kafka console or socket. If I'm getting the data from socket, spark.readstream.format socket streaming instance port. The data is coming to particular socket port. To my port, the data is keep on coming. I can stream the data from socket. We're gonna see the data. We're gonna do a socket streaming from Cloudera to my Eclipse. That's the motto today. Here I'll do a socket streaming, and my Eclipse will be keep on looking out to the socket. See, we'll discuss it today. So socket. So similarly, I can able to provide that. What is my intention here for you to explain is when I have Spark dot read stream format Kafka, this will load the data to my input table. This input table. Once the data loaded into input table, select expression, do all your process here. Once you're done your process, then your data frame will be ready. The processed data frame will be ready. That processed data frame, write stream, where I need to go, I can simply give write, just like write.format, spark.write.format. Similarly, write stream options, format, give the Kafka utils, Kafka params, then start and await termination. This is, you need to give it as a mandatory because of streaming. Hope you know that. This is not a basics, I can say. This is kind of also a medium-based explanation, medium-based processing. Leave out the processing what has been done. I'll explain the processing now. Just don't worry about it. But you can understand, right, all of you, how this works. Guys, are you clear? Or anyone is feel that okay? Okay, let's once hands-on get started, we can able to understand it better. Anyone feel that?
Yes, sir.
Bit hard to understand, I know that, but this is a very advanced streaming API. Very advanced streaming API. If someone is new to Spark, they'll not easily understand this. Who is working Spark for at least for some more time, they can read, they can understand this. You can ask me why, okay? Because if someone is used read a lot, okay, kind of a DSL operations a lot, okay, then write a lot, then they'll understand it, okay, then interlink with the D streams. If who is working with Spark SQL a lot, with the structure stream, they can interlink easily with the Spark SQL who worked on. But still, you can easily imagine this. I'm trying to make it simple. You'll understand after every execution, once I start execution, things will be very easy. Let's go. So, but before this, the data writes into a write stream. In between, there is some small box, okay, some small box, which is nothing but output table. Write it down. Output table. What is this output table is? I'll tell you where the output table is. Before the write stream happens, after performing few SQL operations, there will be a data frame, right? Say, take this example. See, this is what the read stream is, input table. The data got loaded. Once I perform all the SQL operations, this will be happening in a kind of a virtual process. Then that comes into output table. From that output table, write stream will happen. Before write stream, if I'm performing a write stream, the data will be written temporarily to an output table. Then the write stream will happen. To be in precise, if I want to go a bit deeper to it, see, source, input table, output table, destination. But output table is a bit small because that's just for the temporary table till the process writes to destination. Input table, process it to an output table, then from the output table the data reaches destination. Here the process will be that. Input table is incremental include input table. All the data will come and keep on falling to my input table. From where the data gets streamed, reaches to the output table before write stream. Once the write stream is done, the data reaches to the destination. In your case, what I want you to understand is what is input table. You need to understand that. Input table is an unbounded Spark data frame. As I mentioned, unbounded Spark data frame. Please note it down. While I'm performing SQL operations, before the write stream happens, the data comes into output table. Temporary output data frame. And the data reaches to the destination. Please note this everything.
So, Sai, what is the unbounded? Is it no
limit for this?
No limit for the size.
No. Because this is just a virtual, right? It's all about the memory. That's it.
Okay.
Say this temporary table also will be in memory, right?
Yeah. This will be in memory. Just like even Spark streaming, the data D streams is coming, right? All the process will be in memory. The RAM should be so high for that.
The span of the input table is till end of the stream, or we can release the memory in the meanwhile as well.
See, here if the data is in memory, okay. Once the data is keep on streamed, okay. Once the data is keep on streaming, if there is any execution memory is getting lost, okay, there is something known as LRU.
Correct.
Least recently used, right?
Yes, correct. Yeah.
the data will go back to hard disk. Then when I'm performing any operations, if I have use of that word, the data will come into in-memory. Okay. Least recently used. The data of least recently used.
Sai,
Yeah.
once the data is taken, I mean, once it is converted into the data frame in the input table, it
Mhm.
get processed whatever the query we have written.
Mhm.
It get processed and it will write to the output table, temporary output table,
Yes. Yes.
and it will finally go to the destination, right?
Perfect. Perfect.
Okay.
It's see, table is nothing but memory. Simple. Some memory workspace. That's it. Nothing more than that. This input table is a memory workspace in RAM. Output table is some memory workspace. See, I have a large data. In case of what happens, I got the large data into in memory, processed and got got the results, and this will be sent to destination. Same concept, but here we call it as a data frame. Understood, right?
Okay. Yeah. We are making it easy, right? The structured things we are
Yes.
making
We are
it
just
yeah.
making before going to streaming. I'm just making it to a very easy concept. Making it the data to cleansing it. Simple to say.
Yeah, understood.
Yeah. Good to go.
One more question, sir.
Yeah.
If we are getting continuously data, for example, we are getting 100 GB of data.
Yeah.
How will it manage in the real
It will,
time? I
it
understood in the released LRU concept. I understood, but
Yeah.
I have few doubts. I mean, if it get passed, I mean, if you said
Okay.
like it will be. Yeah. I hope you understand.
Yeah. See, first of all, what is execution memory? First, it will calculate. Got it, right? Execution memory. In this execution memory, if the data, the available memory was just 10 GB, for example, okay? And just the data is execution memory, which we have. Execution memory is 10 GB, but suddenly we got 100 GB. Okay? Then there's a concept known as predicate pushdown. That means predict the size and push down accordingly. Push down to hard disk accordingly to get it back once the data got processed. See, I got 100 GB. I have 10 GB as execution memory. Then I'll just push it down to the hard disk till I process the first 10 GB. Once the 10 GB got processed, say for example, I am having a memory of 10 GB in which the data gets processed, and I got the results of 1 GB, right? And again, this will be go back to hard disk. Another 10 GB will come. That get processed. Another 1 GB will come.
So
But this
any
time,
delays? Can we expect?
definitely, if there is no memory, definitely there will be kind of staging.
Okay.
But the work will not stop. It will take a lot of time at least.
Okay.
Then one more important concept is I have 10 GB available. I got the results 1 GB. Okay, 100 GB. One first 10 GB will come, and 1 GB will result of this. My process results is 1 GB. Can now anyone tell me what is my available memory now? How much data will come into RAM now?
9. I think.
9 GB. Because 1 GB is already occupied. What is my execution memory available? 9 GB. Another next 9 GB of this 100 GB will come.
Any enhancement to overcome this situations? I mean, any
No. Because the RAM is not. See, if the memory is available, we can do some optimizations. If your laptop is not supporting more than 1 TB, we can't do anything, right? More than 1 TB. That's it.
So in real time, also we will face this kind of situations.
Yes, when you process it, you'll get something known as stages processed.
Okay.
Yes, it will take a lot of time. If the execution memory is not enough, it will take a lot of time to process the data.
Sai, something is there, right? Only process is only on memory and memory process serializes and something is there, right?
Sorry, Anil? Sorry.
say like this processing something is there like only in that is only on memory and memory plus disk and serialized disk something I wrote I forgot.
CLI.
No, serialization.
Serialization. Yeah. See, obviously this 100 GB can be serialized to reduce the memory, right?
Yes.
I can see, if I say, if the text file I'm getting 100 GB, if I'm getting an ORC file format, the data would be around 30 GB, that's it. Getting it right?
So yes, something four types are there. Like is in only in memory and memory plus disk serialized.
Persistence.
Then maybe I've forgotten something I wrote.
You mentioned about persistence, disk only, memory only, disk and memory.
Yes.
We'll come to that. We didn't cover that. We'll come to that. Caching, that we call it as caching and persistence. Not
Yes.
four, eight types. I'll come to that.
Okay.
You might have seen memory serialized to memory serialized disk, like that, right?
Yes.
Yeah, we'll come to that. We'll come to that.
Okay, thank you.
So good to go, guys, for now. Good, understood, right? The data comes and falls into data frame. From this data frame, process virtual. It's not a physical data frame. Telling you again, this is not even a physical data frame. For the namesake they gave, this is an input table, this is an output table. Till it get processed, the data reaches destination. Making you clear, all of you? Clear, right? Guys? Understood? Good to go? Yes, am I audible? Guys, can you hear me? Yes, am I audible?
Yes, sir.
Yeah. Yes, am I audible now?
Yes, sir.
Yeah. Sure. Okay. So please let me know if you don't hear me, because I am getting internet is not stable frequently. Not sure why. So one second. kind of a programming model of structured streaming. Okay, very basic, which you already know. Okay, input as usual, input table. The data falls into input table. See, it is, I told you, right? Unbounded. The data will be initially like this, then data will be like this. The data will be increasing. The table will be keep on increasing. So here I'll do the process and putting the data to the output table, and accordingly it will go to further destination process. So just the things which we just spoke. Yes, good to go further. Yes, here we are. Okay, guys, shall we start our execution in hands-on from now?
Yes, sir.
Yes, sir.
Yeah. So let's first of all, okay, before going to that, in case of structured streaming, schema definition is mandatory. Please note it down. Schema definition is mandatory to process the data. Please note it down. Very important. Very important. By default, it will fall in the column known as value. These two are very important for you to note it. Please note it. I'm telling you, right? It will fall in some input table. The column will be value actually. Okay, clear, right? So here, when this input table, when it falls into an input table, that comes under column known as value, that will be my reference. So first of all, what we'll do is, okay, let's create a basic program for Spark structured streaming, the very basic program. Okay, coming to, let's say, let me create a folder, structured streaming source. This is my source file. This is my source directory. Inside that, let me create a directory known as data. That's it. This will be my data. This will be my data. Guys, am I audible? What the fuck? Sorry guys, lot of network issues. Sorry. Hope it is audible. Is it audible to everyone? Yes, am I audible? Yes, can you hear me? Yes, am I audible now?
SI.
Yeah, it's a lot of network issues here, guys. My Wi-Fi gone, my hostel Wi-Fi gone due to last high power voltage. So I'm just connecting to my mobile data and working on it. So hope my screen is visible. Okay.
SI.
Can anyone tell me what is the dependency you have used? So what we're gonna do right now? What is the operation we're gonna do right now? Okay. First of all, we have a directory in which we have another directory. Here I'll be getting a text files. Here we'll be getting a text files. In this case, what I'm gonna do right now is create a Spark structured streaming API, read stream, do this looking on this API, create a read stream. Okay, create a read stream and show it in console. Write stream to console. Console is nothing but print. That should be again a write stream. So this is what we're gonna do. As you keep on putting the files in my text files, you can easily see it in a console. Just have a look. This will make you very much clear. Just have a look. But right now, can anyone answer? During the Spark streaming from Kafka, where the data comes and falls, whether it's an RDD or a data frame. Even dstream is a microbatch RDD. What is my question is whether the data comes into an RDD or a data frame. Guys, can you hear me?
Data frame.
No, in case of my dstreams, during my dstreams, I mean to say normal Spark streaming API, do the data comes and falls into a dstream RDD or a data frame?
dstream RDD.
dstream RDD. To have the dstream RDD to do that, what is a Maven you have used? Spark streaming API, yes or no?
Yes.
Dependency. But to do the CSV structured streaming, Spark SQL which you use is more than enough. Is enough. Getting the point? You have Spark SQL, right, Maven? Right? So let me add this and show you, okay? Guess we're the most important phase of the training. Most important phase, very advanced phase where the industry is looking out. Industry is looking out for Spark, but this much of advanced, you're overqualified actually. So I want you to implement all this in your systems. I'm not sure how many people complete the streaming APIs. Streaming up. I told you I gave you 2 URLs to complete it. I could not able to see it at all from anyone. So we are almost ending of the sessions. We are on the end of the sessions. Next week, the most probably the sessions will be winded up. On Sunday, you have Azure deployment of streaming. Not sure how many are on track. Okay. So right now, I'm just commenting all this. Okay. Commenting all these APIs, all these dependencies. These dependencies are not active. I just have dependencies known as Spark Core and Spark SQL. That's it. That's it. I don't have anything. Okay. So let me create a project for you. To achieve this streaming, which stream I am talking about? To achieve this diagram, I don't want any streaming API. I simply need Spark SQL Mayor dependency. That's it I'm talking about. Because there I need a streaming API because that comes into a streaming context and D streams. Here the data falls into a data frame. Data frame belongs to Spark SQL. So Spark SQL is more than enough. So have a look. I just have two dependencies. Hope everybody's with me. Everybody's with me.
Yes, sir.
Hang guys. Just wait. Just a minute, guys. It's a bit slow.
Sai, for adding this Spark streaming API, we have to again do a clean install, right?
Not required. You have Spark SQL it, right? Already.
Yeah, okay.
That's fine. Yeah. So I'm just importing only these, okay? Okay, so the basic setup is done. Okay, I just created a Spark stream, Spark SQL, everything. This is not the basic setup, right? Which you usually do for each setup. So while I'm reading the streams, okay, I'm not, if you see this, I'm not using any streaming context. No streaming context. Nowhere related to anything. But to have it, usually we can do the same CSV streaming using Spark streaming also. But for that, I need to import Spark streaming API, right? The Spark streaming Maven. I mean this one to do it. But here I'm not having it. I'm just having SQL everything. I'm not initializing anything. But if you check Spark dot read stream, can you see that all of you? API known as Spark dot read stream.
Sir.
Yeah. So this comes with the Spark session API itself. So here we can able to not only stream using Spark context, but we also able to stream using Spark SQL data. Making you clear? Spark SQL data frame. So here, if I'm using Spark read stream, just have a look. So what is my intention is in this data, let me have some data in my I'll take few of the data here, which I have. Okay. I'll have few source data here, but my data is like here. Any data reaches here that needs to get streamed. So here I need to perform few CSV streaming. I'm just copying the CSV streaming. Okay? CSV streaming. See, let me just write this out. Okay, I'll go line by line while reading this. See, val CSVDF equal to dot read stream spark dot read stream dot. I'll not give any separation now. I'll do normal stream. Okay, dot read stream dot CSV. Read stream dot CSV. So let me give the path. This should be my path. This should be my path. So I have just given a path. Guys, this is something very important for you to understand. Okay, this is something very important for you to understand. Once I give this spark.readstream.csv, whatever be the data present in this directory, that comes and fall inside my input table. Please understand this. What I'm giving this, that comes and falls into the input table. You can't get the data out of the data frame. The data directly comes and falls into your input table. You can't take the data into data frame. You can't even print it. So this is a data frame, right? Okay. Let me show that csvdf dot show. This is what you usually do, right? Spark.read.csv. Yes or no? All of you? Everybody's with me? Yes, everybody's with me? This is what you usually do, right? csv.read.csv. But when I do with read stream, if I'm giving show, okay, what is happening is the data is directly go and sitting in my input table. This is an unbounded input table. So you can't simply give a show for it. Show this. No, you can't do this. When you do a read stream, definitely you have to do the write stream. That is mandatory. Show will not work. Will not work. When you do a read stream, the data goes into input table. When you do the write stream, the data comes and falls into console. So let me run this, okay? I'm just reading spark.readstream.csv. Can you see one of the questions here? Do you remember I mentioned something?
Schema.
Yes, schema must. Yes.
Schema is mandatory. Okay. Let me define one of the schema. Okay. Let's say this is my schema. While reading the stream itself, it is providing an issue, because while reading itself, it provided this issue. Till write, it didn't come. Till show. Okay. Okay. I made a struct type dot option. I'm directly accessing this weblog schema to it. Okay, schema. Sorry. Okay. So once I'm done, let me run this. So I'm providing the schema also. I'm asking whatever the data present in this directory, read that stream, and impose this to the schema and run this.
Sai, Arun here.
Yeah.
I have a question. So
Yeah.
we have a display and show, right?
Sorry?
We have two. One is show and other is display.
Display?
And show.
Okay. Display.
Yeah. So when to use
Where-
display and when to use show?
You mean to say for each or println or display?
No, we have option called display, right? Display of the data frame.
I never used.
Okay.
Okay.
So-
Display. Okay. Okay. Go ahead.
So display of the data frame we use. I'm not sure. We using this commands in database actually. So
Okay.
show of one is this data frame dot show. Other is display of the data frame. So I'm not sure when to use that display and when to use show. So
Not sure. Like, I know the display in part RDBMS, but in Spark display. Okay, let me check on it because I never use the display. And how far? Not sure. Let me check on the display part. Yeah.
Sure. Yeah.
Yeah. So if you see, guys, I'm giving the show, right? Can you see this? What is it? What is it specifying?
Write stream.
Write stream. Okay. Let me do something now. Now what I'll do is csvdf dot write stream dot option. To place it in console, I need to give it as console. Sorry. Output mode and format. Yeah. Just have a look. Let format is enough. Write stream dot format dot start dot await termination. So this is no way related to streaming context. Can you see that? Read stream schema CSV. Write stream format console start. Shall we run this now, all of you? But one thing very important is checkpointing. We'll discuss what is checkpointing is. We're gonna go deeper to this checkpointing now after this. Okay, give a checkpoint directory location. Okay, some location for checkpointing. So here what I'm doing, I simply made Spark session, created a weblog schema, CSV Spark read stream. I gave schema, gave CSV, write stream format console. I mean print it in console. Write it to my console. Okay. Option checkpoint location. Have a look. It's not showing any issues. Can you see that, all of you? All good? It's waiting for, but it's running. It's waiting for the stream. Can you able to understand that? Here I do not have any data. That's the reason it is not streaming any data now. If I place any data now, can you see it? All of you, data which I have is, this is the one. Can you get it now, all of you? Guys, can you understand? Okay, let me place another file. Let me place another file.
So the data is directly fall into the directory, right? Read stream directory.
No. Read stream is not a directory. It's an unbounded input table. That's not a directory. See.
No, I'm saying that C we are given some path, right? File C.
This
structures.
one.
Yeah.
You know what is happening? This files has been fetched and put into Spark input table. From that, I'm writing the stream. These three files are sitting here. Here my files are sitting. You got the point, right?
Yeah.
My files are sitting. I put
the files is there directly fall into that
input table. From that input table, I'm writing the stream.
Yeah.
Since I didn't perform anything, the same data will come into output table because I don't have any operations. From this output table, I'll be putting the data to console.
Yeah, we can give HDFS path also, right?
Yeah, we can. Possible. Arun, that's not a physical input table. It's a kind of a virtual memory in memory. That's it. Yeah. So what I'll do is, let me do something. There is a 6, right? CSV streaming. Okay, let me place another file. Okay, 66. Okay. Pasting it here. Keep watching at the bottom. Keep watching the Eclipse. Got the data, right? All of you? All of you can able to understand? I placed one more file. You got the streams? Yes or no?
Yes, sir.
Let me place another file. What are the image? What are the 6, 8, 10, 66? Okay. Let me create with another name. 77. Okay. What I have in this 77? These 3 values. I'm copying this 77 and pasting in data. You can see the data. Why I'm saying this again and again is, let me do something. I'm deleting the 77 from this directory. Okay, I'm deleting it completely. And again I'm placing the 77. Just have a look. Taking the 77 again and pasting it here. Do it will stream or not? If I'm pasting the 77 again here, it will stream or not?
Stream, sir.
I think no, sir, because there is a value column, right? Kind of a reference.
No. Okay. Okay, I'm pasting it. Okay. See the expectation. Is it streaming?
No.
No. The reason is, once it is streamed, it will be recorded. The file name will be recorded. Okay, you can ask me where it is recorded. Now come to checkpointing. Checkpoint location. Go to this checkpoint location. Sorry, Jay. Am I audible to everyone?
Yes, I.
Okay, I'm going to the checkpoint location. Okay, this is the sources. There is offsets. There is a commits. Okay, go to offsets. You can see some data which has been sent. Take any offsets. Just a minute. File name commits. Can you see the file name here? All of you? So everything will be recorded. This is a source happened. 66. What is the first file name? So once it is streamed, it will not push the data again. So simple. Checkpointing is something records the each source of the stream. Maybe it's a CSV streaming, whether it's a socket streaming, whether it's a Kafka streaming. Will not bother about it. Checkpointing. I'm just mentioning of the checkpointing. Everyone can able to understand this? All of you?
So size same data will get processed if we change the file name.
Obviously.
Oh,
Yeah.
okay.
Let me do something. No. Let me do same input. Okay. I did sounds and didn't process, right? So I'm changing it to 88. See the Eclipse. 88. See the console at the bottom. Pasting 88. Can you see that? Super fine.
Yes, sir. Yeah.
Yeah. So say for example, I'm deleting this 88, pasting 88 back again. It will not process. So it is recorded. So checkpointing is something which you can note it down. Checkpointing is something it will save the source information. You can say source information as well as transform information also, transformations also, information on sources as well as transformations.
Suppose,
Sorry, Ashish here.
yeah, suppose if we remove from the checkpoint file, I think it will pre-process,
It
correct?
will create. Yeah.
We are able to see the data, but we are not giving any show or something. It's a write stream. It will provide the detail about the data.
See, write stream in sense, if you give console, it will save here. If you give Kafka, it will write it to Kafka. Getting it? You got the output table, you got the input table, then you are writing it. Where you want to write it? Okay, console. Okay, write in console. If you want to write it into Kafka, I need to provide the Kafka information down the line.
Here we are seeing each batch wise output.
Yes.
So after saving, we can see all detail what we already write into the output.
You mean to say all the data, full data frame?
Yeah.
No, you can't see that because that's a kind of a streaming, right? You remember in Spark streaming, in normal D streams, once we got the D streams, you pause and put the data, converting into a data frame. Once the data convert into put the data into data frame into Cassandra, the same data frame will not have the information. Yes or no?
Okay. So in that parallelly we have to store somewhere, then we can see in Cassandra or some database or somewhere.
Cassandra is not possible, only Kafka.
Okay.
Sync is a problem, but the thing is like, I'm not sure there's a right time to mention aggregation. During aggregation, you can see the entire table. I'll come to that. Okay.
Okay. Thank you.
So this is what the micro batches happens, guys. Hope everyone is clear, right? The data is directly coming and falling inside a data frame. But you can ask me why the separation is not shown. If you enable this property, have a look. You just keep this as a separation. Okay, I'm stopping it right now. And let me include this read option here because it is delimiter as colon. So if I'm separating it, mapping it to weblog schema, So which consists of 2 columns. Then I change the checkpointing, because if I change the checkpointing, it creates a new directory. It will not have any new records. From batch 0, it will start again. Hope you understand. If I change the checkpointing, it will start from batch 0 again. Getting the point? From the same data, there is no change. But if I change the checkpointing location, it will start with batch 0. Getting the point, all of you? Guys, before it was 25. Before it was 25. These files are already processed. That is already recorded. If I change it to 26, so another directory gets created. Checkpointing. To the checkpointing, these files are new. So it will stream all this data. Getting it? All of you?
Yeah, yes, sir.
Yes, sir.
Yes, sir.
Yeah. So let me run this now. Can you see the data? Let's start with batch 0.
Yes, sir.
So let me put one more file. Okay, now come to the point. Now let me put a JSON file. This is JSON. This is nowhere related to any CSV, but I'm putting this data into here because that value is new. Just have a look how it works. Can you see this? Any data you send that comes and falls into this data frame? Yes or no? Getting the point, all of you?
But here
Yeah,
structure is
but
different. How it is picking?
Sorry?
schema is different actually.
Schema is different here.
Yeah, see, schema is different, but it is showing null, but it is coming to data frame, right? It is coming to data frame. First of all, if I provide one schema for it, okay, providing some schema for it, this is coming from input table. This data is coming from input table, fetching from input table and mapping it to name for the schema which I provided. The data is coming to input table and I made an output table with 2 columns. Getting the point? From here it is fetching here and showing it to console. Give me the point, Ram.
Yes, I got it.
Yeah.
Sai, can you go to the Eclipse one?
Yeah.
Okay. So here in the name section, we have this device ID 1 comma something and all. So there are more records inside that name?
Yeah, because it's just showing top 20, right?
Okay.
It's just like show. Show will show only 20 records, obviously. But you can see it again. But here we need to provide truncate everything. Here it is getting truncate, right? In show, what you usually do, show false, so that it will not show any truncation. To eliminate that, here you have to put one more option. Dot option, truncate false. Not stream anything because these records are already streamed, right? So let me change the name. Devices 1. Just one second, guys, one second. Yeah, so let me place this. Let's have Eclipse open. Oh, it will take, okay, just a minute. It will take the prefix. Do I already pasted it? Some issues with stream. Just a minute. In the checkpointing. Can you see that? All of you? Remember to understand this? Truncation false.
If these values inside the name we want to get, we need to use that explode, right?
No. We do have few operations in structure streaming to achieve it.
But in normal JSON?
Yeah, you can get it as a data frame. This is also as a data frame. You can. Possible. Getting it right. You need a device ID as one of the columns, and you need 1 in it, 1, 2, 3, 4, 5 in it. That is possible.
Yeah.
Going forward, I'm gonna execute it at the bottom.
Okay.
Yeah. So that's how the read and write stream. Getting the point, all of you so far. Any questions? Any questions, guys? Am I making you clear? Guys, getting it or not? How it looking like? Is it so tough to understand? Hard to understand? Arun, you can find everything in the documentation. I'll be providing all this documentation. Everything you can remember. That's not a problem. You can find in Spark documentation also. So everything will be easy actually.
True, but during the interview, right? It's a difficult thing. We learning, yeah, like we learning, we working on the session, we writing codes. That's fine. Like, but I'm not sure. Like when the interviewer asks some question, will be remembering all the syntax.
Maybe, but if you execute all this, if you don't do any copy paste, like if you're typing it on your own and trying to achieve something on your own, so that scenarios will obviously give you answers during the interviews. Maybe. So.
I few of the scenarios, like when we are working on it, is pretty different.
Sorry, Abhishek.
Yeah, means as I told you, I have moved to the big data platform now.
Yeah.
While working, the scenarios which we are encountering are like unexpected. Like means maybe we can use those scenarios while telling in the interview.
Yes. See, there are, I worked on almost 7 projects of big data and 4 to 5 projects in Spark. I told you, right? Each project, they're using Spark for different purpose. Each place. I remember, I told you, right? I remember when we met in the Pune WSH, the very first project in my big data life, in my entire big data life, when I'm entering to the first project, my first project was Spark structured streaming. No Hive, no Scoop, no Spark streaming also. Spark structured streaming is my first project.
Yeah.
And after that, completely Spark streaming, then Spark SQL, right now completely Scala. So that's what, each will have different encoding problems, different usage, blah, blah. But the thing is, like, when you are in interview perspective, when you see, say, for example, if you are using, since Arun asked me how to kind of remembering issue, again, if you ask me to write a code for explode for JSON nested of array, you'll not remember it now. If you see the code, if you have copy pasted, you can easily remember it, right? So you can able to say, okay, I'll use explode here. Simply you can put it like that. They'll not expect much, I believe. Not like exact code without any syntax issue or compile issue. You can simply say, like, read stream how it works. I need to use a separator. I need to use a schema for it, read it, and I'll use a write stream. If I need a format, I'll use console, etc., etc. That can help you. Yeah. Arun.
Yeah, sir. Yeah.
What do you say for this, Arun?
No, remembering the steps. See, remembering the steps is fine. How we have to execute, like what order. First we have to read, then we have to do the processing and writing to some location. That's everything is fine. Like that is how it executes. But when it comes to the real syntax, right now, even you execute for 3-4 times and you go out of your job. When you go out of go for the regular job and coming back for the same interview and remembering all those.
Very hard, I believe. Totally very hard. Yeah. But since if we find no option, we have to look on it every day, looking on it.
Yeah. I agree with that. The reason why I'm asking is, like, is there any simple way to remember the syntax? Something is there. It's a common.
Simple. See, for common syntax instance, even though I'm taking out with Arun, in this case, you just read string. You made CSV, right? If I go with socket, instead of putting CSV, you'll put socket here. That's it. Getting it right.
Okay.
So that way you can able to simply remember it. Like, I need to put it as format. Socket. Like that. If Kafka. Socket. If it is socket.
Okay.
You're gonna do it for CSV, you're gonna put CSV. So such a kind of loopholes you can actually put it as a mark. That's it. Yeah.
Okay.
Here CSV can read also JSON, right? You should.
See, this is JSON, right?
Yeah, I'm saying.
The name is CSV, but actually text. Any text file. That may be JSON also. Text might be from JSON also. It is reading it. But not convert as an exact data frame. I'll show that going forward. How to convert this as a data frame, etc. We just started execution.
Okay, it reads Avro like that. Avro.
Oh, no, not Avro. Recently, Spark structure streaming recently bought Avro 2.4.3. They recently started using Avro structured stream.
Okay.
When I was working in structured stream, the requirement was to use Avro, but we failed to do it because there is no proper APIs with that. So right now in 2.4, they released it. I was using 2.2.1 that time, 2.1.0. Sorry.
Yeah, XML also we can read. Right?
Not XML.
Sorry, what are the formats are possible and what are not possible?
Here, CSV, JSON, ParQ, Avro. Sorry, ORC, ParQ, Avro was a recent one. Yep. So if you can able to see .parq like that, you can simply read stream. It comes like that. But you need to give the proper schema for it, etc., etc. You need to properly deserialize it. But stick on with CSV for now, because understanding structure stream is a big task. But going forward, once you execute two things, you'll understand. You'll try with many different formats also. Things makes easy. Shall we go ahead? Shall we do socket streaming now? All good?
Yeah. Sai, if possible, can you show in Avro file reading also?
Avro, I didn't include this since it's a very new API. I'll include this. I'll include and give you the document, this doc.
Yeah. Okay.
I'll put everything, socket CSV, Kafka, everything. Since it just released last month, Avro, I'll include that.
Okay.
Yeah.
Actually, in that DBS bank, he asked how to read Avro. That's why
How to read Avro as a stream
Avro file.
or a...
Other than data frame, he's saying.
You asked me, right? Other than data frame, no.
Can you read with RDD? Like,
Recently, I worked with Avro, but as a data frame, I worked with. Not in streaming. As a batch, I worked with Avro, but it's completely a data frame. Directly, I'm using a Spark SQL data frame, but not RDD. Actually, I got such requirement to make it as an RDD. After you asked me, I remembered you when I was doing it. So, but finally, because I have some issues with the partition, write with partition, etc. So I need to convert, I need to write it as an Avro RDD, but I didn't find any solution for that, actually.
okay.
Yeah. So, okay, let's go with socket. Let's take a socket, okay? So how to read a socket? Same. Well, socket df is equal to spark dot read stream dot format. What is socket? There will be a host, there will be a port. I have to keep listening to that port. Once I got the information, I need to grab it. Getting the point? You know socket, right? Socket streaming. Socket is simple, guys. There will be a host, there will be a port. Do I make clear? All of you? Guys, are you clear?
Yeah, sorry.
Yeah. So socket is, so I need to format as socket. Okay. What and all I need? Just see the socket information. Socket syntax. Options, load. That's it. You know what is this? My Cloudera IP. Same IP. I started listening to 9999 port. And let me write this. Socket df dot write stream dot format. For now it's console, right? Dot mode append. I'll come to this mode, okay? Dot option pointing syntax.
Hey, double is a source, right? From that port we are.
This is port. Yeah. This is my source socket.
Yeah.
Source port in this particular host. Right? So now I'm write stream, sorry. Write stream dot format console mode should be okay. One sec. Mode. Output mode, sorry. Output mode append. It's just like mode, okay? So we have few more appends, I'll come to that. So we have update complete and all. So socket df write stream format console output mode append option checkpointing dot start await term. That's it. Now I'll push the data to this particular port from my Cloudera, and my Eclipse will be keep listening to that port. Have a look. I think I already have this checkpoint. I'm changing the checkpoint. Okay, yeah, got it. So let me open that port. It is showing connection refused because I didn't open that port. Anybody aware of Netcat? NC Netcat? Netcat is kind of used to interacting with the port also. So I'm using Netcat of all of L. I'm giving 999. That's it. If I give this, I can send data to this particular port, 999. So my connection is open. So let me run this now. If I type the data here, the data can be read it out here to this particular socket. Okay, it started reading it, no issues. Let me send the data. Can you see the value now, all of you? Is getting it?
Yeah.
Socket streaming. This is just a very basic value. I'm just giving it as just typing it. Getting it, all of you so far? Socket streaming.
So
Okay.
where are you storing it after streaming is done?
This one. So this is if I stop, this data is lost. I'm not saving any data here. I'm just printing it out.
Something should. Okay.
Right.
Yeah.
And guys, if they ask you the question whether the socket stream or CSV streaming is possible only in your structure streaming, no. Even in D streams, we can do socket streaming and CSV streaming. Possible. I didn't show because I want to show that in your structure streaming as a part of it. That is also possible. Okay, getting it. Socket streaming is also possible using D streams. I'll give you the syntax, but don't say like that. Okay, only structured streaming it is possible. No, not like that. Making it clear.
Yes, Sai. Sai, if you want to stop reading means stop only, dot stop.
No, dot stop. I can even directly terminate it, start, and then if I want to stop it, start, wait, stop. That's it. I'm stopping it for now. But as a part of streaming, there should not be stopped because it will not come out of streaming if I'm stopping it, first of all, right? It becomes batch. So this is socket. Socket streaming is something looking. See, can you see the column name here? That comes with value. Even with Kafka, that comes with value. Am I making it clear, all of you? So coming to one small introduction, this how the CSV streaming works. We discussed. Write stream, we discussed. Trigger processing, we didn't discuss yet. Even trigger processing is not possible with our version which we are using. Okay. So this is what a normal write stream we saw. Socket streaming as usual, we saw that. This we didn't do any transformation yet. Going forward, we're gonna do it. Okay. This is a Kafka streams. Okay, we'll do the same process here, which we are seeing here in Kafka streams. So guys, can we have a small break and meet back? We'll wind up at 1:30 or 12:35 for sure. For 2 to 3 minutes, we'll take a break. Will that be fine? Because before I start Kafka, I need it to be a bit fresh.
Sure, Sai. Sai, just like one thing, I have prepared that JSON file which I wanted. Can we try after that?
Yeah, post the session. Shall we try that, Debusesh?
Yeah.
Yeah, sure. Yeah.
This is what I was saying. Yeah.
Debusesh, your voice is breaking, I guess. Maybe issue from my end.
No, Sai, actually, I'm having some internet trouble.
Okay. Guys, other guys, can you hear me, right?
Yes. We can able to hear you.
Okay, sure. So, okay,
After yeah.
Yeah, Vamsi?
Yes, I after the session, I need some 2 minutes.
Yeah, sure. We'll sit. Most probably we'll end up by 12:35 kind of, or 12:40. We have 20 minutes. At 1 I have other session, 20 minutes I have time. We'll discuss on it. Yeah,
Thank you.
sure. Guys, can you hear me? Yes, am I audible?
Yes, sir.
Yeah. Yeah. Okay. Okay, let me put Kafka now. I'm reading through Kafka. Okay. If I'm reading through Kafka, as usual, read stream. Hope everyone can able to see my screen, right? Guys, you got? Guys, am I audible?
Yes, sir.
Yeah. So yeah, so I'm giving a format as Kafka now. I'm not going with the format of CSV or socket now. I'm going with Kafka. Okay, I'm going with Kafka. So once I go with Kafka, I need to provide the details of subtopic, bootstrap servers as usual. We need a offset reset, bootstrap servers, and topic names, everything, right? So I'll give everything during the read stream itself. So once I read the stream, I'll have a column like this. Can you see the columns, all of you? Right? So I'll get such a data frame. I'll get such a data frame. So let me run that. Okay, my God, I didn't switch on Wi-Fi. One second. Okay. Meanwhile, I already have I think the product producer. Okay. Now let me include the code for Kafka. Okay, same Kafka. In options, I need to provide for everything, blah blah kind of like bootstrap servers, etc. So this is my host name. This is my port where my Kafka is running. This is my topic. That's it. I just gonna change the Kafka and removing all this. Everyone is clear so far? Are you clear with this? Format Kafka, option Kafka bootstrap servers, localhost 1992, subscribe topic name. Everyone is clear with this code?
Yes.
So let me run this. I need to change the checkpointing. Okay, my bad. Okay, so I forgot something to say. Okay, what is the issue? Everyone saw the issue, right? What is the issue I faced? What is the issue? What is it?
libraries.
Guys, you remember to get the data through Kafka, I included one of the dependency known as Spark Kafka streaming. You remember that? Oh my God. Okay. You remember that, all of you? All of you remember that, right? So let me open the dependencies. Guys, please respond now, please.
Yes.
Yeah.
I know, I can remember that.
Let's take this form. I included Spark SQL, Spark Core, Spark SQL. I included streaming also. I included Spark Core, Spark SQL. Along with that, I included streaming, but I used a connector, Spark Streaming Kafka connector. Can you see this, all of you? Yeah, but this connector is with respect to streaming. But here I'm not doing any streaming to Kafka, right? I'm not doing any streaming to Kafka. Instead, I need to add one of the dependencies that is nothing but Spark SQL Kafka dependency. We have. Please note it down. This is important for Kafka's structured streaming integration. For normal D streams, we usually include dependency as Spark Streaming Kafka. This is for D streams. This is for structured stream. Please note it down. What is the reason? Sorry, Vasu. Yes, am I audible?
Yes, sir.
Can you say it one more time? Okay. See, for D streams, we have included one of the POM known as Spark Stream with Kafka. Yes or no? You remember that? Guys, am I audible now? Guys, am I audible now?
Yes, sir.
Yeah. Oh my goodness. Yes, I'm audible now?
Yes, we can hear you.
Yeah. So for Spark, for Spark D streams, we added one of the dependencies known as Spark Streaming with Kafka, right? Spark Streaming with Kafka. Even though we included Spark Streaming, we need to put this integration. Am I audible? To my voice is breaking?
No, fine, looks fine.
Yeah. So in this Spark Streaming, even though I have Spark Streaming, using the Spark Streaming, I can do CSV streaming and socket streaming. I can do that. I can do CSV streaming as well as socket streaming using this streaming. But when I integrate with Kafka, I need another dependency known as Spark Streaming with Kafka. Spark Streaming with Kafka. Similarly, to have, in case of structured streaming, for CSV and socket, for CSV and socket, it is fine to have Spark SQL dependency. Yes, one sec. Some dog is shouting. Just let's go. Okay, sorry guys. So if I'm having any D streams, I'll go with Spark Streaming APIs with Spark Structures, Spark Streaming Kafka. Through Spark Streaming, I can do CSV and socket. Kafka, I need this dependency. Similarly, using Spark SQL dependency, I can do this too. But with Kafka, I need this dependency. For doing sockets, CSV socket, Spark Streaming API is enough. I mean, this is enough. But with Kafka, I need this. Similarly, to do structured streaming with Spark SQL with CSV and socket, Spark SQL is enough. But with Kafka, I need another dependency, which is this. This one. Can you see this? All of you? Spark SQL Kafka. Guys, can you able to understand this?
So you're saying for Spark Kafka streaming, we have used this Spark streaming with Kafka. Now it is fine to having with Spark SQL Kafka to structure stream, right?
Exactly. For D streams, for normal streaming APIs, you need a CSV in socket, you need streaming API. This one is enough. But to do with Kafka, we included this. Similarly, for Spark structured streaming with socket and CSV, these two is enough. For structured streaming with Kafka, you need this extra API, Spark SQL Kafka. Can you see this? All of you?
Sai, for socket one, which two is enough? Yes,
for socket, this is enough, Devasish. Getting it? Okay, let me repeat it.
Yes, I. If you are using only Spark means we need this dependency only Spark. If you are integrating with the Kafka and Spark means we are using these
exactly
dependencies. Correct?
Exactly. Perfect. With streaming API, we need this Kafka. With Kafka streaming, for Spark SQL dependency, we need this Kafka in structured streaming. That's the difference. Getting the point?
A lot of disturbance from your side. Lot.
These people are shouting like hell. Fine now, all of you? Fine now? No issues?
Yes, sir.
Yeah. So I'm repeating again, for CSV and socket, streaming API is enough. With Kafka integration, we need Spark streaming Kafka dependency. With structured streaming, I need Spark SQL is enough with CSV socket. Spark SQL Kafka dependency, Kafka is enough. Clear, right? So that's the reason I included one of the APIs known as Spark SQL Kafka, because Spark SQL means structured streaming. This means Kafka integration. Normal Yes, can you hear me?
Yes, sir.
For normal streaming, for socket and CSV, this is enough. For Kafka integration, we need this. In case my structure streaming I need, instead of struct streaming, I need to replace it with SQL. That's it. It will agree. Getting it? This is for structured streaming. This is for normal streaming. This is for structured streaming. Sorry. This is for structured streaming. This is for normal streaming. Getting it right? Dependency. Shall we go ahead?
Yeah, yes, sir.
Yeah. So done. Then I need to have few more APIs, like importing all blah blah, because I'm having all this imports. We don't require any Spark streaming APIs. Done. Let me run this now. Oh my god, oh my god, oh my god, wait. My Wi-Fi is on. Yeah, call ra. Akka call. Disconnect. Yes, I
Sai, your
didn't
voice
talk
not
anything. I didn't talk anything. I'm just sticking with the laptop. Hope I'm audible, right?
Yes.
So here, so I'm just running this again. Okay, since my Wi-Fi was on, like the data got consumed. So for now, I'm just streaming it through console. Okay. Yes, we're winding up in another 2 minutes. Please. I'm trying really hard to fix all the issues. I'll be winding up, and I know I'll be winding up. So just have a second. I'll be winding up. Okay. I'm roaming here and there to shut the noise. I'm finding a lot of network issue. I'm trying to connect it because I need to show this. You have a task to complete.
Sai, are you in Hyderabad or Chennai?
Yeah, Hyderabad.
Ah,
There was a sudden high voltage issue last night, so modem got blasted in my hostel. So that's the reason these many network issues happen.
Oh.
Just got resolved. I just went out, right? Just got resolved. They get the new connected to the hostel now, Brindavan hostel. So see, guys, when I do the Kafka streaming, okay, so these are the columns which we usually get, okay. I already told you. Somehow we'll be continuing with Kafka tomorrow, but I just want to show this. Once I start producing the data, data will come like this. So what is this? Can I know? This is a value which I just sent. Can I know this? This is a value which is getting it here. Can anyone tell me what is the reason for getting it like this? It's not the actual data which is showing.
Yeah, we need to. No, we need to go to the Kafka. Yeah.
String serialization. So I have to do that string serialization here itself. Dot source dot select ex here. Cast. If I make this as a string, things will work out. So I'm just input table got loaded. Now I'm casting it as string. I'm just deserializing it as string. Now I'll stop it and rerun it. Done. The data is waiting. So if I try to produce the data, can you see that now? I just selected a value here. I can select any number of columns here, but I just selected a value. So it is just deserializing it. So before that, just concentrate on this syntax, okay? Spark.readstream.format Kafka. These are the options. I'm just writing it to console. So just consuming the data from Kafka. That's it. So tomorrow we'll be producing it. We'll be processing a JSON file in structured streaming and move it further. Clear, right, all of you?
Yes, sir.
Yes, sir.
Yeah. So tomorrow we'll be having the session. Like I just give it 2 URLs, right? I think only one person complete the 2 URLs. I think Jay is rocking actually in this entire batch. Jay is one who is very aggressive in completing the task. So remaining people, please complete the tasks. I gave you 2 URLs. I asked you to fetch username from one, other one is index. Please try to complete that by tomorrow. Tomorrow you have a lot of tasks to complete because the most important phase of the training is tomorrow and the next week, 2 days. So because we're in at least in advanced too. So in structure streaming, I'm gonna give few scenarios for you to implement and execute it and show it before Wednesday. So before that, complete those 2 tasks. I gave 2 URLs. Hope you remember. You have the data already, I believe. Do it. Clear? I don't give any structured streaming doc now. Nothing as of now for today. Complete those 2 tasks first. Then we can complete structured streaming tomorrow. Tomorrow we'll be starting up with NiFi because we are left out with Kafka and output modes and just writing to Kafka. After that, we'll be starting with NiFi tomorrow. Clear?
Sai, in Kafka, do we need to give like here serialization, deserialization syntax? Right?
Not required. Not required. We'll be getting this is a data frame, right? See, you remember, since it's an RDD, we are deserializing it, right?
Correct. Yeah.
Here it's not an RDD. Directly data comes and falls into data frame. So that's the reason I'm applying the cast for the column. Can you see that?
Yeah, correct. Value.
I'm applying the cast. I'm reading it as a string. That should also happen in the form of a data frame inside a data frame, because my data comes and falls into a data frame. Clear, right? No transformations is done. Directly the streaming data comes and falls into my data frame. So anything you do, that has to be done in data frame. I know, bit tough, hard to understand, very advanced, but this is what they're expecting. I think I'm trying to make it simple, but since it's a hard, still it may look hard, but once you start executing it, things will be easy. Okay, guys, clear? Good to wind up? Guys, can you able to hear me? Good to wind up. Shall we meet tomorrow?
Yeah, yes, I.
Sure.
Yes, I.
Yes,
Okay. Fine.
Sai, if you can wait for
Yeah,
5
Devasish
minutes.
and I think Devasish and Vamsi have some issues. You just stay back. I'll be back in a minute, guys. I'll just have some water and come back. Meanwhile, just start sharing your screens, okay? We'll quickly see that. What is that? And then we can wind up by one. Yeah. Thank you. Yeah, Vamsi, Debasis.
యా సాయి
Yeah, share చేయండి Vamsi. Yeah, చూద్దాం.
సాయి అది ఇష్యూ కాదు, అది యాక్చువల్గా ఏంటంటే అది స్పార్క్ స్ట్రీమింగ్ స్పార్క్ సీక్వెల్ ప్రాజెక్ట్ స్టార్ట్ అయిందని చెప్పా కదా మీకు.
అవునవును. Yeah.
అది యాక్చువల్ గా వాళ్ళు ఆల్మోస్ట్ 30 స్క్రిప్ట్స్ ఇచ్చారు సాయి, అది ఫినిష్ చేసాము. బట్ ఏంటంటే దాన్ని ప్రొడక్షన్ మూవ్ చేయాలంటున్నారు. సో ఫస్ట్ ఏంటంటే యూఏటీలో రన్ చేస్తున్నాను అన్నారు, బట్ దాని ప్రొడక్షన్ కి ఆ జార్స్ ఎలా మూవ్ చేయాలి సాయి, ఎలా అది ప్రాసెస్ ఎలా ఉంటుంది?
జార్స్ మీ చేతిలో ఉన్నాయా?
జార్స్ ఉన్నాయి.
ఓకే, ప్రొడక్షన్ మూవ్ చేయాలంటే అక్కడికి వెళ్ళి రన్ చేయమంటున్నారా?
ప్రొడక్షన్ ఇప్పుడు డైలీ స్కెడ్యూల్ చేస్తాం కదా సాయి నార్మల్ గా.
యూఐటీలో ఉన్నాయి, రన్ అవుతున్నాయా స్పార్క్ సబ్మిషన్ స్క్రిప్ట్స్?
ఇంకా రన్ కావట్లేదు సార్. ఇప్పుడు ప్రొడక్షన్ లో ఎట్లా సెటప్ చేస్తామో ఆ సెటప్ చేసి వాళ్ళకి ఇస్తే వాళ్ళు ఫస్ట్ యూఏటీలో రన్ చేస్తారంట. అంతా వ్యాలిడేషన్ అయిపోయినాక దాన్ని ప్రొడక్షన్ మూవ్ చేస్తా అన్నారు. ఎట్లా ప్రొడక్షన్ సెటప్ చేస్తామో సేమ్ అదే సెటప్ నాకు ఇవ్వండి, యూఏటీలో రన్ చేస్తామంటారు.
ఓకే, అది రిక్వైర్డ్ డేటా యూఎట్ లో ఉందా?
ఉన్నది సాయి. మా ఇక్కడ ఏంటంటే మాకు టెస్టింగ్ కోసం సమ్ శాంపిల్ డేటా ఎక్సెల్ ఫైల్లో ఇస్తే దాని నుండి మేము హైవ్ టేబుల్లోకి లోడ్ చేసేసుకొని చేస్తున్నాం అనమాట.
ఓకే, జార్స్ యాక్చువల్ గా విన్ఎస్సిపి ద్వారా మూవ్ చేసేయచ్చు జార్స్ ని. కాకపోతే ఏంటంటే ఆ జార్ డిప్లాయ్ కి స్పార్క్ సబ్మిట్ కమాండ్స్ అన్ని రాసారా మీరు?
రాసాం సాయి.
అయితే మీరు జస్ట్ స్క్రిప్ట్స్ జార్స్ కాపీ చేసుకోండి.
ఓకే, ఈ ఒక్కొక్క సబ్మిట్ కమాండ్ వచ్చేసి ఒక్కొక్క షెల్ స్క్రిప్ట్ లో పెట్టుకోమంటారా?
పెట్టుకోవాలి, బికాస్ అది ఒక్క ఇండివిజువల్ జార్ కదా.
అవునవును,
ఒక్కొక్క స్పార్క్ సబ్మిట్ కమాండ్ ఒక్కొక్క షెల్ స్క్రిప్ట్ లో పెట్టండి. ఆ స్క్రిప్ట్స్ ఒక్కొక్కటి ఎస్హెచ్ కమాండ్ లో పెట్టి షెడ్యూల్ చేసేయండి, క్రాన్ లోను ఊజీలోను. థింగ్స్ విల్ వర్క్ కదా.
ఊజీలో. ఓకే 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 ఓకే.
కానీ డైరెక్ట్ స్పార్క్ సబ్మిట్ కమాండ్ ఇవ్వకండి, షెల్ లోనే ఇవ్వండి ఇప్పుడు, బికాస్ షెల్ యాక్చువల్లీ వర్క్స్ స్పార్క్ సబ్మిట్.
యా, సో షెల్ స్క్రిప్ట్ లో ఇస్తాం సార్. జస్ట్ షెల్ లో స్పార్క్ సెగ్మెంట్ కమాండ్ ఉంటుంది అంతే.
చెప్పాలంటే అన్ని షెల్ స్క్రిప్ట్ అన్ని స్పార్క్ కమాండ్స్ ఒక షెల్ స్క్రిప్ట్ లోనే ఇచ్చేయచ్చు మీరు.
అంటే రీస్టార్టబిలిటీకి మళ్ళీ ప్రాబ్లం అయితే
అవుతుంది. జస్ట్ టెల్లింగ్ యూ క్యాన్, బట్ కాదు నాకు ఒక్కొక్కటి ఒక్కొక్క టైంలో రన్ అవ్వాలి అంటే సపరేట్ షెల్ స్క్రిప్ట్ వచ్చి 20 స్క్రిప్ట్స్ క్రియేట్ చేసాను.
ఓకే, సో వీటిని పెట్టేసుకొని మామూలుగా ఊజీ యాక్షన్ లో ఇచ్చేసుకుంటే సరిపోతుంది.
షెల్ యాక్షన్ ఇచ్చేయండి సరిపోతుంది.
యా, షెల్ యాక్షన్. ఓకే ఓకే, అదే నాకు డౌట్ వచ్చింది ఎలా ఇస్తారు అనేది, ఎలా అనేది.
ఇప్పుడు ఐడియా వచ్చింది కదా మీకు?
నాకు అర్థమైంది సార్.
ఓకే ఓకే
మీ దగ్గర అదేమన్నా సాయి, మీ దగ్గర అట్లా ఊజీ స్క్రిప్ట్స్ అని ఉంటే షేర్ చేయగలరా మీరు ప్రొడక్షన్ డిప్లాయ్ చేసి?
అది మా రన్ స్క్రిప్ట్స్ ఉన్నాయి, కాకపోతే అవి షేర్ చేయకూడదు నా ప్రొడక్షన్. శాంపిల్ నేను చూస్తా ఉంటాయి ఎక్కడ
ఇక శాంపిల్ చూడరా, ఏదన్నా జస్ట్ నార్మల్ శాంపిల్
చూసి
ఏంటంటే అది మండే నుంచి అది ఇంప్లిమెంట్ చేయాలి. సో దీని వల్ల నేను అసలు ఈ టాస్క్లు కూడా చేయలేకపోయాను సార్. లాస్ట్ యాక్చువల్గా 3 weeks టైం ఇచ్చారు, 1 week ఓన్లీ మామూలుగా మ్యావిన్ అని సెటప్ కి సరిపోయింది శాంపిల్ ప్రోగ్రామ్ రన్నింగ్. ఈ 2 weeks లో ఆ 30 స్క్రిప్ట్ మేము ఇద్దరమే ఉన్నాం అనమాట, ఇద్దరం కొత్తనే. సో
నేను చూసి పంపిస్తాను మీకు మరి ఊజీ స్క్రిప్ట్, మనం డిస్కస్ చేద్దాం శాంపిల్ దొరికితే. ఓకే, Debasish, thanks Vamsi. Debasish?
Yes, am I audible clearly?
Yeah. Can you share your screen?
Yeah. Actually, Sai, I'm in not in my home. It's in my friend's house. I'm giving you a sample data. If you can see. So what I'm trying to achieve is that I was trying to automate a process in which I'm hitting a ServiceNow URL and getting the JSON file.
Okay.
And this JSON file I wanted to compare. I'm intending to use data frame to convert between this data's JSON data frame and a CSV data frame and do some manipulations.
Okay.
So if you see, there is a column called records, and inside it, like the way you showed, right, there are fields, short description, sys updated on kind of thing. I want to convert the records inside this one into a data frame. So should I use how to proceed with this one? Should I use explode or something?
Obviously, you have to use explode of results tag.
Okay. Actually, I just got it yesterday, so thought of checking because I
Okay, you can. This is fine.
Explorers?
The same. Even though you can use the same code as well. I also found it as a valid one.
Yeah, this is valid design. Yeah.
Yeah, just a valid one. Okay. We just need to convert into data frame, isn't it?
Yeah, I want to convert
Which
to a
field you
data
want in
frame.
that results?
Sorry.
Which field do you want in that results?
I'm actually mainly looking at the sysid, but the field. But if entire thing can be converted to a data frame, it can be
Not
help.
entire you can convert the position, but the entire thing is possible. But you need to give individual IDs.
Okay. So
Just wait for 5 minutes. I'll
description.
convert the data frame and give it to you. Check.
Oh, okay. Can you share screen?
Yeah.
సాయి ఇప్పుడు ఊజీలో ఫర్ ఎగ్జాంపుల్ థర్డ్ యాక్షన్ దగ్గర ఫెయిల్ అయింది అనుకోండి సాయి, అక్కడి నుంచి దాన్ని రికవర్ చేయాలంటే ఏమన్నా ఉందా సాయి?
దానికి సేమ్ ఇప్పుడు ఫ్లో చార్ట్ లాగా ఈక్వెన్స్ పెట్టాలి దానికి. లైక్ ఇక్కడ ఫెయిల్ అయితే బ్యాక్ టు దిస్, ఇక్కడ ఫెయిల్ అయితే అని చెప్పి లాగ్స్ చూసి లాగ్స్ నుంచి ఒక ఐడి ఫెచ్ చేసి ఆ ఐడి నుంచి మనం ఫెచ్ చేయాలి. కొంచెం ఒక షెల్ స్క్రిప్ట్ రాయాలి దానికి అంతే.
Sai, just as an FYI, Gaurav, right? He has, I think he has went to US for MS.
But he told he went for Canada, right? He tried for Canada.
No. He went to US for MS, and that's the reason he told me to. He called me actually yesterday.
Okay.
He was saying he was unable to join classes, but I'm watching the video.
But the current US part is, what to say, not right choice currently to go to US. They're expecting there is some recession in next other 1 year.
That could be.
Canada and right now Canada, Australia as not Australia, sorry. I found this as one of the options. Like
even Netherlands is also good, right?
Netherlands. I was about to say that. Netherlands.
Okay.
That is good right now.
Oh, okay. So I have seen like many of my friends going to Netherlands and Germany right now.
Yeah, Germany right now it is going on. But Netherlands, yeah, Germany is also fine, but not as much as mechanical part in IT there.
Okay.
European were developing a lot.
Yeah.
I think there should be a SysID column, SysID and description.
Sorry, SysID.
I think there should be a SysID and a description column.
Okay. No. Oh. Is it records or results? Oh, okay. It's working, Devasesh.
Sorry, actually, I was also thinking the same thing, because you showed the last JSON, which is similar.
Okay.
Right, the one which you showed for explode.
This one?
No, the one when you showed us the explode scenario, right? The one when you want to break, if you have some nested.
Yeah.
You have to use explode. Yeah, I was thinking the same thing. Actually, Sai, if there any special characters in one of the columns, will it impact the data frame?
Depends on the character. Not maybe. See, in case of JSON, if I have any characters inside this like comma separation, inside value, that may hinder. Got it right?
Okay, like carriage return or something, it can.
Yeah, only this comma semicolons might hinder. Depends on the data again. If
Okay.
not an issue. It will comes inside the data frame. It's not a problem.
Okay. So actually, yeah, I was troubleshooting one issue on that. So I have made the code for handling the special characters using reg replace.
Yeah. Okay.
So I was thinking of doing a QA/QC. So that's the means I want to develop a code for QA/QC check. So that can help.
Yeah, that can help. But this data don't have any issues actually.
No. Actually, this is the right record. Means I have just taken the record which doesn't have any issues, because the actual data is huge. So I just gave a sample record. But I will look into that special characters issue, and if required, I will.
Yeah. Let me know. Sure, Devasesh. Yeah. Sure then.
Yeah.
Have this code, it will work. And select all the columns.
Yeah.
Record start. Yeah.
Yes. Yeah.
Okay. Okay, WC, sure. I'll connect to other meeting actually that starts by 1.
Okay.
Please send me if you got such a special character JSON. Yeah.
Yes, sir. Yeah, sure. I will.
Thanks, WC. Yeah.